week and 2 days since we did the lab, and there is actually very surprising, but there's actually much visible sign of crystal growth, as you can see. Some environmental conditions that affect crystal growth are temperature of the solution, as an increased temperature will cause the solvent to evaporate faster, which will increase growth, obviously. The glass vial, I put it near the window of my dormitory. My room is 70 degrees Fahrenheit, but near the window it's probably around 60 degrees Fahrenheit. That's not that conducive to growth. Pressure seems to play a role in crystal growth, though there is no visible pressure other than atmosphere pressure applied to the glass vial. All right, let's move on to calculating theoretical yield. I use this equation: 2 aluminum solid with the aluminum we put in, KOH, potassium hydroxide, H2O water, 4H2SO4, sulfuric acid, KAl. This is the alum. This is the part we care about. That's water, hydrogen. All right, so this is the equation that has been balanced with the correct stoichiometric coefficients. All right, so we measured out exactly 1.0 grams of aluminum. Therefore, 1.0 grams of aluminum. If we put in the molar mass, we get, cross out the G's, right, grams, we get 0.0371 moles of aluminum. We take that and we put that through the ratio, right? 2 moles of aluminum, 2 moles of alum produced. That goes away, so it's a 1-to-1 ratio. So 0.0371 moles of aluminum, also 0.0371 moles of alum. We take that and we convert it to grams of alum. Cross that off, and this number right here I got through the molar masses of potassium, aluminum, sulfur, and oxygen. I made sure to multiply oxygen by 4, add sulfur, multiply all that by 2, as you see, and added aluminum and potassium to get that number. And we get 9.56 grams of alum is the theoretical yield. So zoom out and take a quick look at that. Right, next we need to calculate the actual yield. We massed the alum after it's solid precipitate, 7.55 grams. The formula to figure out the percent yield is actual yield divided by theoretical yield times 100. Our actual yield was 7.55 grams over 9.569 grams, according to right here, if you remember, 9.56 grams. That was the theoretical yield. Times 100, and we get 78.9%, which is quite high. I'm very happy to see that number. I was actually expecting something around 30-40% yield. All right. So some factors that could have affected an experiment yield that was not exactly 100%. It's pretty impossible for it to be 100%, but some factors were that while the alum was being gravity filtered, obviously not everything goes through the filter paper, as the filter paper emerges wet. Okay, so some grams of alum could be lost when we were gravity filtering it into the glass vials. More could be lost when transferring from the beaker to the vacuum filter apparatus. Presence of impurities in the aluminum foil could result in an experiment yield that's not exactly 100%. This part is pretty obvious, because just because the scale says we have 1 gram of aluminum foil, that doesn't mean we have 1 gram of the aluminum element, right? Al. Aluminum foil is not 100% aluminum. It's about like 98.5% pure aluminum. So there we go. Those are some reasons why our experiment yield is not exactly 100%. And that is all for today. Bye.